All right, today we're going to pull back the curtain on something you probably use every single day. How does your GPS figure out the absolute fastest route to get you from A to B? We're diving into the AI brains behind that, and you'll see it's actually a pretty fascinating race between different problem-solving strategies.
I mean, have you ever really stopped to think about it? It feels like magic, right? 1 second, you're lost. The next, you have a perfect path. But it's not magic. It's actually a set of really clever algorithms navigating a mind-boggling number of choices to find the best one.
So to get a handle on how this all works, we're going to use this simple little maze. The goal is easy. Get from S for start over to E for end. Now the zeros, those are open paths. The ones, those are walls you can't go through. The real challenge for an AI isn't just finding any path, it's finding one efficiently without wandering around forever.
So how does an AI search smarter and not just harder? How does it avoid checking every single dead end? Well, it uses a secret weapon, a kind of educated guess that helps it make better decisions.
And that secret weapon is called a heuristic. Now don't let the technical term throw you. All it really is a smart shortcut. A heuristic doesn't know the perfect path. It just gives the algorithm a good hunch, an estimate, of which direction looks the most promising. It helps it place its bets, so to speak. And this is the perfect way to picture it. The compass gives you a general direction. The treasure is over there, but you still have to figure out how to get around the walls and cliffs and everything else in your way. A heuristic just keeps the AI from wandering off in the complete opposite direction. Okay, so with that key idea of a smart guess in our back pocket, let's meet our 4 contestants. These are 4 different algorithms that all use heuristics to solve our maze. Think of it like a race, where each one has its own unique strategy for crossing that finish line. First up, we've got Greedy Best First Search. I like to call this one the impatient sprinter. Why? Because its entire strategy is based on one simple question. What move looks like it gets me closest to the goal right now? It always picks the path that seems like the biggest shortcut. So here's the deal with Greedy Search. It's a trade-off. It's blazing fast because it doesn't waste time thinking too hard. But because it's so focused on that immediate gain, it can easily get tricked. It might take a path that looks good at first, but turns out to be a really long detour. It absolutely does not guarantee you'll find the best route.
Okay, next up is A-star, or as we'll call it, the balanced strategist. Now, unlike our sprinter, A-star is way more thoughtful. At every single step, it looks at 2 things: how far it's already come and its best guess, the heuristic, for how far it still has to go. This balanced approach makes A-star incredibly powerful. In fact, it's guaranteed to find the shortest possible path, every time. But that perfection comes at a price. To be sure it hasn't missed a better option, A-star has to remember every single path it's ever considered. And on a big, complex problem, that can use up a ton of memory. So what if you want the perfection of A-star, but you don't have all that memory to spare? Well, that brings us to our 3rd contestant, Ida-star, which stands for Iterative Deepening A-star. Think of this one as the efficient minimalist. It wants the perfect answer, but without all the baggage.
So how does it do it? It's pretty clever. Instead of one giant, memory-hogging search, it does a series of smaller, deeper searches, going a bit further each time. This uses way less memory. The catch? Well, it might end up re-exploring the same paths over and over again in each new search, which can sometimes slow it down. And finally, we have beam search, the pragmatist. This algorithm looks at all the possible next steps and says, you know what, there's no way I could keep track of everything. So at each step, it only holds on to a small number of the most promising options, a beam of possibilities, and just throws the rest away. Being pragmatic is great for saving memory, for sure, but it's also a big gamble. By narrowing its focus so much, beam search runs a huge risk. What if the actual best path was one of those options it decided to throw out early on? Too bad, it'll never find it. It's trading a shot at perfection for raw efficiency.
All right, our contestants are ready. The impatient sprinter, the balanced strategist, the efficient minimalist, and the pragmatist. They've all had a crack at our maze. So, let's see the results. Who won?
And the result is... well, that's interesting. It's a 4-way tie. Greedy, A-star, Ida-star, and beam search. They all found the exact same path. They all navigated the maze perfectly and came up with the very same solution.
Which probably has you thinking exactly this question. Hang on, if they all got the same answer, what's the big deal? Why do we even have 4 different strategies if they all end up at the same finish line?
And that's the key right there.
Our maze was basically a 100-yard dash. It was a short, simple track. On an easy course, the different strategies of a sprinter versus a marathon runner don't really show. But in a true marathon, a hugely complex problem, like routing all the data on the internet or a robot navigating a city, that's when their underlying approaches to speed, memory, and accuracy become completely, critically different.
So the real lesson here isn't about finding the one best algorithm. It's about choosing the right champion for the right competition. It all comes down to the trade-offs.
This table really sums it up. If you just need an answer and you need it right now, greedy or beam search are your sprinters. If you absolutely, positively have to find the single best path and you've got memory to burn, A-star is your champion. And if you need that perfect path, but you're working on a system with limited resources, Ida-star is the smart, minimalist choice for the job. And this isn't just a theoretical puzzle. These smart search strategies are quietly running the world all around us.
That GPS in your car is using a version of this to navigate the ever-changing maze of city traffic. The AI enemy in your favorite video game is using it to hunt you down in a way that feels intelligent, not just random. The robots in giant warehouses are navigating complex floor plans to get you your packages. Even massive logistical puzzles, like how an airline schedules all its flights, are solved using these very principles. And this quote from the source material really hits the nail on the head. The power of these algorithms isn't about brute force. It's about intelligent focus. By using that smart guess, that heuristic, they can slice through a ridiculously large number of options and find answers to problems that would otherwise be completely unsolvable. So we've taught our machines how to find the smartest path through mazes and maps and massive webs of data. The really exciting question now is, where do we point that incredible ability next? What new worlds, what new challenges in science or medicine or logistics are just waiting for the right kind of smart search to come along and solve them? That's something to think about. Thanks for tuning in to this explainer.